That's new.
Good afternoon, everyone. Welcome to today's webinar, part of our Managing California Groundwater webinar series. We'll give everyone a few minutes to get started. As you are joining us today, we would love to see who we have in the room with us. Encourage you all to type your name, your organization, and your location into the chat. We will get started in just a minute. Nice to see some familiar faces and names. Okay, for those of you just joining us, as you're joining, please type into the chat your name, your organization, and location, and we're going to go ahead and get started. Today's webinar, as you can see, will be recorded and available following today's discussion. If you do have to jump off at any point, we'll make sure to share the link to the recording with all registrants. My name is Emily Finnegan. I am a water project manager at the Local Government Commission, and I will be facilitating today's webinar discussion. As some of you know, Local Government Commission and Maven's Notebook have been hosting a number of webinars on topics of interest related to the sustainable groundwater management implementation and coordinated groundwater planning. And we can share links to some of those previous webinar conversations, including webinars on coordinating across the Integrated Regional Water Management Program and Sustainable Groundwater Management Act, CV salts, and the ILRP, Irrigated Lands Regulatory Program coordination, as well as today's webinar, which is a part of a three-part webinar series. Today is the first session in this three-part series that will share key learnings from the Groundwater Leadership Forum's 2020 Groundwater Sustainability Plan review. And included in this series will be providing detailed guidance on how future groundwater sustainability plans in 2022 plans can address specific areas of interest. And today, we're excited to be focusing on interconnected surface waters, groundwater dependent ecosystems, and engaging environmental stakeholders in groundwater planning. And with that, I will turn things over to Chris Austin, the fabulous owner and manager of Maven's Notebook and the Groundwater Exchange.
Hey, thank you, Emily. Good afternoon and welcome to today's webinar. My name is Chris Austin, perhaps better known to you as Maven, and I publish 3 websites on California water. The Groundwater Exchange is a website which collects and organizes reports, documents, tools, and other resources for SIGMA implementation. These resources include pages on undesirable results, projects, and actions, and other topics of interest. And there's a video gallery of all kinds of videos on SIGMA and relevant topics. And you can sign up for a free bi-weekly SIGMA implementation newsletter that will keep you abreast of new resources being created by the Department of Water Resources, NGOs, and others. There's also an in-depth introduction to SIGMA that's available in both English and Spanish. Today, we'll be posting links to the pages on interconnected surface waters and groundwater dependent ecosystems, which have links to the resources that our speakers will be highlighting today, as well as other relevant information. And I just want to let you know, we'll soon be launching a new main page for the Groundwater Exchange, so stay tuned. Briefly, I just want to mention my other websites. My main website is Maven's Notebook, which is a website devoted to California water news and information, where 6 days a week I publish a comprehensive California water news aggregation, plus coverage of meetings and conferences not found elsewhere. And there's even breaking news alerts for the really die-hard water people. That's at mavensnotebook.com. And the California Water Library is my other website. It's an online archive of documents curated from state agency websites and others, and includes research documents, policy documents, reports, and more. And I actually did a lot of curating before the state agencies took a lot of their documents off their website. So if you can't find it there, I suggest trying it at the Water Library. That's at cawaterlibrary.net. So thank you again for tuning in today. And now I'll turn it over to you, Susanna.
Great. Thank you so much, Chris, for that great introduction. My name is Susanna Sossman, and I'm a project manager at Ag Innovations, where I serve on the facilitation team with Joseph McIntyre for the Groundwater Leadership Forum. I just want to explain a little bit about the Groundwater Leadership Forum. It's also known as the GLF, and it's a coalition of conservation, clean drinking water, and community development organizations that's convened by the Water Foundation. They've been working together for the past 3 years to support the successful implementation of SIGMA, and you can see the members listed here. And then the organizations listed in the top right-hand corner: Clean Water Action, Union of Concerned Scientists, Audubon California, and the Nature Conservancy. They formed a subgroup within the GLF to review 31 GSPs submitted in 2020 in critically overdrafted basins. And they used an evaluation matrix that specifically focused on drinking water, climate change, stakeholder engagement, and ecosystem health in their analysis. And then from this review, they created a summary analysis of their findings and are now offering these webinars to showcase their learnings from their analysis and to support 2022 basins in GSP development. You can find both the summary report and the evaluation matrix they used for their reviews on the Groundwater Exchange website that Chris spoke about, and we'll link to that in the chat here. And with that, I'll hand it back over to you, Emily.
Excellent. Thank you, Susanna. And so excited to be able to work with Ag Innovations in leveraging the knowledge and the expertise of the Groundwater Leadership Forum. And with that, I will introduce our fabulous speakers today. We'll begin with Melissa Rhodey, who is a groundwater scientist for the Nature Conservancy of California. I don't have time to go into her wonderful and impressive bio, but I'll post it in the chat now. And just a reminder, as Melissa is presenting today, we encourage you to type questions in the Q&A function of the Zoom webinar or into the chat directly. And we will have about 30 minutes at the end of presentations to respond to some of those questions. And also as a reminder, in the Q&A function, you'll see a little thumbs up next to the questions. You can upvote a question that you'd like to see our speakers respond, and that will help us to prioritize those questions. So with that, I will turn things over to you, Melissa.
Great. Hi, everyone. Can you hear me?
Yep, we can hear you.
Okay, great. For those of you who don't know who the Nature Conservancy is, I'm just going to start off with a little brief introduction of who we are and what we do. We are a global environmental organization whose mission is to protect the lands and waters on which all life depends. And we're a science-based organization. We have more than 500 scientists working across 72 different countries in all 50 states. And here in California, we own and operate more than 500,000 acres of land, which we use as living laboratories for scientists to conduct their research in, for the public to recreate in, and also that we use for working agricultural land. The sustainable water management, sustainable water management in California is really important and crucial for achieving our mission, and also for operating our preserves and preserving the plants and animals that make California the global biodiversity hotspot that it is. For those of you who don't know, California is a global biodiversity hotspot with more species than the rest of the United States and Canada combined. So at the Nature Conservancy, we've witnessed the impacts of groundwater depletion firsthand at our preserves. On the left is just some drone footage from one of our properties along the Santa Clara River in Ventura County. It's located at the border of the Fillmore and Piru groundwater basins, and it's about more than 500 acres of native riparian forest that abruptly died during the last 2012 to 2016 drought. These native riparian woodlands support threatened and endangered species such as leaf-spills vireo, and southern willow flycatcher that are protected under federal and state endangered species acts. The extensive mortality that you can see here during the last drought is directly linked to groundwater levels exceeding 24 feet below ground, which is too deep for the roots of these native cottonwood and willow species to access groundwater. Recent research out of University of California, Santa Barbara has found that a depth to groundwater needs to remain within 12 feet beneath these riparian woodland types so that their roots can access groundwater during drought periods, such as the one we're entering in again this year. So for failing to prevent groundwater conditions in the basin from causing adverse impacts to groundwater dependent ecosystems, such as this type of widespread mortality, especially for those that provide such crucial habitat for listed species, is not only significant and unreasonable impact under SGMA, but it's also subject to other state and federal laws. On the right is another property that we own along the Cosumnes River at the border of the South American and Cosumnes groundwater basins. And these valley oak woodlands, such as these, they look like they're in good health and actually look like a nice picnic spot as well. But in fact, they're what we would refer to as the living dead. And that's because the forest floors are completely devoid of saplings and young trees that are needed to replace the mature trees once they die off. And valley oak is a very iconic species to California. You see it, when you're driving around throughout the state. And they're some of the valley oak are some of California's deepest rooting phreatophytes with roots that go as deep as 80 feet. So to prevent groundwater conditions from adversely impacting California ecosystems, it's absolutely critical that groundwater sustainability agencies evaluate how groundwater levels and depletions of interconnected surface water are impacting our groundwater dependent ecosystems. And this is because over the last century, our state has lost 95% of our wetlands and river habitat due to land use changes and groundwater changes, amongst other reasons. As a result of the habitat loss, the remaining groundwater dependent ecosystems are biodiversity hotspots, providing critical refugia for threatened and endangered species. And some of these species, such as the desert pupfish, which is endemic to California and completely dependent on groundwater fed springs. If groundwater depletion occurs, that species can go extinct. Since the inception of SGMA, the Nature Conservancy has been working hard to ensure that sustainable groundwater management considers the needs of both people and nature. Using the Nature Conservancy science that my colleagues at Jeanette Howard and Matt Merrifield developed to map groundwater dependent ecosystems in California back in 2010, we were able to raise the importance of groundwater for ecosystems during the drafting of the Sustainable Groundwater Management Act. And then the picture on the left, second from the right, is our Director of External Affairs at TNC California, Jay Ziegler. In the ensuing years, TNC partnered with the Department of Water Resources and the Department of Fish and Wildlife to develop what's called the NC dataset, which is short for the natural communities commonly associated with groundwater, which is a starting point for groundwater sustainability agencies to map groundwater dependent ecosystems in their basin. So recognizing that groundwater sustainability agencies are required to address groundwater dependent ecosystems for the first time, my colleagues and I have been working really hard to develop the tools and resources that groundwater sustainability agencies need to get the job done, especially within these short timelines of getting plans developed and implemented. These tools include the Groundwater Dependent Ecosystem Guidance Document, which provides a step-by-step process starting with the NC dataset to considering and incorporating ecosystems into groundwater sustainability plans. Also, we have remote sensing tools such as the interconnected surface water mapping tool that Charlotte will be presenting, and the Groundwater Dependent Ecosystem Pulse, which is pictured here on the left. It is basically, it's a tool that provides 35 years of vegetation health trends from the Landsat satellite record. And for all the mapped features within the NC dataset, in addition to providing the local climate and groundwater data that's available. And then on the right, we have our Groundwater Resource Hub, which is also hosts a wide range of data sets, like a routing depth database, guidance documents and best practices, latest research and case studies on groundwater dependent ecosystems. So another really important type of technical assistance that we've been providing GSAs with is engaging with them directly, either through working groups, such as, like, for instance, Santa Cruz County, they had a surface water working group that we were a part of. Technical meetings with consultants and GSA staff to help give feedback on the specific situation in their basin on groundwater dependent ecosystems and interconnected surface waters, and then also public comment letters, which all these things fall under the umbrella of stakeholder involvement. The working groups and technical meetings with the GSA staff are a fantastic way for GSAs to get involved stakeholders such as the Nature Conservancy. Many NGOs and government agencies such as the U.S. Forest Service and the Department of Fish and Wildlife don't have enough staff or financial resources to attend all of the GSP public planning meetings. And so writing letters is often an efficient means of communication. And as Susanna mentioned, in 2020 and 2021, the Nature Conservancy reviewed and provided comment letters for all the 2020 GSPs. And we also plan to review and provide public comment letters for all 64 of the draft and final 2022 GSPs. And we're doing this in partnership with other NGOs through the GLF that Susanna talked about. And all of us collectively represent the interests of disadvantaged communities, tribes, and the environment, and also the impacts of climate change on these various user groups. So for the remainder of this talk, I'm going to share with you the 5 common areas of concern that the Nature Conservancy had with the 2020 Groundwater Sustainability Plans, which we found inconsistent with best available science when addressing environmental beneficial uses and users of groundwater. So our first concern is related to how groundwater dependent ecosystems were identified and mapped in the plans. We found that 47% of plans did not sufficiently identify and map groundwater dependent ecosystems. The 3 main methodological flaws that we found that GSA is doing were, 1, that they would use one point in time to characterize groundwater conditions around groundwater dependent ecosystems to determine which had a depth to groundwater greater than 30 feet. And in the process disregarded seasonal and interannual groundwater fluctuations characteristic of California's Mediterranean climate. And so the problem with relying on groundwater levels from one point in time is that it doesn't acknowledge that many plants have adaptive water stress strategies to deal with intermittent periods of deep groundwater levels. So if you're taking groundwater levels from 2015 and that you got the depth to groundwater was 40 feet, that if you're using that as to determine which ecosystems have less than 30 feet, you're going to basically remove that polygon incorrectly. And because that ecosystem may be relying on that groundwater levels shallower in wetter and more average years, if that makes sense. Secondly, we found that a lot of GSAs did not contour groundwater's depth of groundwater to account for land surface. And this is problematic because many wells are located up away from rivers and streams. And groundwater dependent ecosystems exist in the low-lying depressions of the land surface that are closer to the water table. And then lastly, we found that there were some places, some GSPs that basically used the presence of surface water and assumed that the ecosystem was surface water dependent and not groundwater dependent without looking at groundwater conditions. And just to remind you all, groundwater dependent ecosystems are defined under the GSP regulations as ecological communities or species that depend on groundwater emerging from aquifers or on groundwater occurring near the ground surface. So you can have a groundwater dependent ecosystem that exists whether surface water is present or not. And a lot of these phreatophytes in California tend to rely on both water types. So They can be facultative and not only have to depend on groundwater to survive. The second main area of concern was around interconnected surface waters. And so we found that 57% of the plants didn't sufficiently identify and map interconnected surface waters. And one of the main reasons we found this a bit faulty was that there was a lot of unreconciled data gaps. And shallow monitoring wells are a massive data gap throughout California. However, the absence of evidence is not the evidence of absence. And so we saw many plans exclude potential or actual interconnected surface waters because they lacked adequate data. But Sigma, as we all know, is based on adaptive management, and there's and reconciling data gaps. And there's general recognition that we don't have all the information we have right now, but we need to fill those data gaps and to the best of the ability that we can. And the Nature Conservancy recommends that all stream reaches with data gaps be retained as potential interconnected surface waters until sufficient data proves otherwise. It's absolutely critical that we use a conservative approach in the absence of data, especially since many streams in California are home to threatened and endangered species. Another major issue that we saw is that intermittent streams that are dry some portion of the year were not mapped as an interconnected surface water. Interconnected surface waters are defined by the GSP regulations as surface water that is hydraulically connected at any point by a continuous saturated zone to the underlying aquifer, and the overlying surface water is not completely depleted. And so at any point has both a temporal and spatial component. And as you can see here and on the right, there's a little conceptual model showing, this is from the Pasamnas. It's showing how in some parts of the year you have dry conditions, but in the wet season you have groundwater is coming closer to the surface. So it's still interconnected. It's just over different time scales, not let alone spatially. Third area of concern was related to sustainable management criteria. And this is quite concerning because this is basically the heart of Sigma, is trying to achieve sustainability and how we're defining sustainability. And what we found is that 73% of minimum thresholds in the 2020 plans did not even describe potential impacts on environmental users. And so, California species can rely directly or indirectly on groundwater with varying responses, as I described earlier in the presentation. And potential effects on groundwater-dependent ecosystems need to be described when we were defining what an undesirable result is for the basin. And their water needs need consideration when we're establishing minimum thresholds and measurable objectives, so that we can ensure that groundwater conditions throughout the basin are not causing adverse impacts on these species and ecological communities. Another area of concern was around stakeholder engagement. This little table here is from DWR's guidance document on stakeholder engagement. And what we found is that 96% of plans did not address environmental stakeholder comments. And you can see here in the second column, the consulting column, public comment letters, focus groups, surveys, public meetings. These are ways that stakeholders can be consulted, and then they can be involved through workshops and whatnot. And so, as I mentioned earlier, the public comment letters was the most efficient way for a lot of NGOs and even resource agencies to be able to provide comment in an efficient way across the whole state. And we provided comments on both draft GSPs and the final GSPs that were submitted to the Department of Water Resources. And while we recognized that there was a very, timelines were really tight around the 2020 GSP development, and also that consultant costs are high. So like if you have requested changes, having to incorporate those are high. It's really important that GSAs plan early to engage stakeholders in the basin. The public comment letters are not really the most ideal time to be providing feedback. Earlier is better, which is why the workshops and working groups work really well, I think. And so The Sustainable Groundwater Management Act requires that GSAs consider the interests of all beneficial users and uses of groundwater. However, groundwater needs for historically marginalized groups like the environment, disadvantaged communities, tribes, can be difficult to quantify and even integrate into these groundwater sustainability plans without stakeholder input. So, like in 2020, we're going to be reviewing the plans again in 2022 and providing comment that way. But we also invite folks to reach out to us individually before those letters come to you, if that's an option. The last area of concern was around monitoring networks. 70% of the plans did not address shallow monitoring well gaps. And I mentioned this earlier in the interconnected surface water. And even in regards to the GDEs, it was a concern. The installation of new wells that can better characterize groundwater conditions under GDEs, streams, disadvantaged communities, and tribes really need to be prioritized to ensure that these beneficial users are not being adversely impacted. In regards to groundwater, they're essentially the canaries in the coal mine. They're the ones that have the shallowest wells. They're the ones with the most sensitive ecosystems. And so it's really important that we're monitoring them to make sure that they're not being impacted by groundwater pumping and management in the basin. So to wrap it up, our recommendations are that GSPs utilize best available science and show the work, so that when people are reviewing, stakeholders are reviewing the plans, we know what was done. When data gaps exist, that GSPs be conservative until there's sufficient data to remove things or prove otherwise. That GSP development and implementation prioritize stakeholder engagement with all beneficial users, especially historically marginalized groups. And then that you partner with NGOs, academics, and federal resource agencies to help fill data gaps. And if you are a member of these, or an NGO or academic or federal resource agency, like making sure that the data that and the programs that are being implemented at these different institutions that can help facilitate the successful implementation of SGMA by sharing knowledge and data. And then reconciling data gaps, because SGMA is all about adaptive management. So SGMA provides California the opportunity to sustainably manage groundwater resources for current and future societal, economic, and environmental benefits. And the inclusion of natural communities in the management of our state's groundwater resources is essential to protect and restore our public trust resources, such as wild and scenic rivers and habitat for federally and state listed species. These important ecological assets and the benefits they provide our society can only be protected under SGMA if environmental beneficial users are being included in the plans. Thank you for your time, and I look forward to engaging with you all in the questions.
Excellent. Thank you, Melissa. And we're already getting lots of great questions in the chat and in the Q&A. So excited to get to those. Charlotte, I will turn things over to you. Next up, we have Charlotte Stanley, who is a Conservation Technology Associate for the Nature Conservancy. And again, as a reminder, please feel free to type your questions into the chat and Q&A, and we will get to those at the end. Take it away, Charlotte.
Okay, great. Can you all see my screen?
Yep, we can.
Okay, great. Thanks, Emily. So I'm Charlotte Stanley with the Nature Conservancy, and today I'm going to focus on interconnected surface water and tell you about a new data set and online tool that will help you understand locations of interconnected surface water in your region. So SGMA requires GSAs to consider interconnected surface water, which I'll abbreviate as ISW since it's a bit of a long name, in their groundwater sustainability plans and to avoid significant adverse impacts to ISW. So the Nature Conservancy developed this new data set to help GSAs identify locations of ISW in their basins. And we encourage GSAs to use this data to help map ISWs in their 2022 GSPs. Under sigma, interconnected surface water is defined as surface water that is hydraulically connected at any point by a continuous saturated zone to the underlying aquifer, and the overlying surface water is not completely depleted. So in simpler terms, when surface water in rivers and streams is connected to groundwater through a continuously saturated zone, this is ISW. There are two types of interconnectedness. First, if the surface water is gaining water from the groundwater, shown on the left here, where the groundwater table is higher than the stream surface. This water seeps into the stream, thus called gaining. The second type is a losing stream, where surface water is still connected to groundwater, but the stream water is seeping into the groundwater. This is shown on the right here, where the water table falls beneath the river surface. So why do we want to identify sources of ISW? This source of water is crucial for people and nature because it remains steady throughout the year, even after the winter rains stop. And it's especially important to sustain stream flow and vegetation during drier periods. With ISW, any excessive pumping of groundwater can reduce the surface water supply, impacting nearby vegetation and ecosystems, and often altering the water flow, turning gaining streams into losing streams. By understanding this link between surface water and groundwater, and by knowing the locations of likely ISW, GSAs can better manage their local water resources. This new data set we developed uses groundwater depth as a proxy to determine ISW. We developed this data using groundwater elevation data available online from DWR, which this image shows a screenshot of the web tool where we downloaded the raw data. The DWR data is represented as continuous raster layers that approximate feet above or below mean sea level, based on groundwater well measurements. These measurements approximate the groundwater levels in the unconfined to uppermost semi-confined aquifers. Using this available data, our methods do not account for perched aquifers. The data is available for spring 2011 and 2012, and for both spring and fall from 2013 to 2018, and is only available within the Central Valley. So we downloaded these 14 raster layers covering 2 seasons over 8 years. And these next few slides show a few examples of the different seasons. This is spring 2014, fall 2014, spring 2015, and fall 2015. As you can see, each season's data set doesn't cover the exact same region, depending on the well measurements available that season. And we incorporated this information into our data set so you can get a sense of the certainty of our data. So to determine ISW, we overlaid the rasters for each individual season. This image shows a graphical representation of the groundwater level for one season in light blue in comparison to the land in tan. Looking at all 14 seasons together, we calculated the average, minimum, and maximum groundwater elevation. Next, we subtracted these elevation grids from a statewide elevation data set to find the depth to groundwater. The resulting layers represent the mean, minimum, and maximum depth to groundwater expressed in feet below the ground surface. In this example here, spring 2014 had the minimum depth to groundwater from the surface, and fall 2015 had the maximum depth to groundwater. We then assigned these minimum, maximum, and mean groundwater depth values to river and stream segments across the valley using rivers from the National Hydrography Dataset. We finally classified each stream on its likely ISW status, categorizing the likelihood of the connection between surface and groundwater. The connection status is based on the minimum depth to groundwater over these 14 analyzed seasons. Using minimum depth to groundwater for this categorization provides a conservative estimate of ISW, identifying streams as interconnected surface water if they have been connected to groundwater at any point between 2011 and 2018. ISW is classified into one of these 4 categories. Likely connected gaining. In these streams, groundwater depth is at or above stream surface levels and thus is likely flowing into the surface water body. Likely connected losing. Groundwater depth in these locations is between 0 and 20 feet of the stream surface level and is likely receiving water from the water body through a continuous saturated zone. The third category is uncertain. In these instances, groundwater depth is between 20 and 50 feet below the stream surface and may or may not be connected to the surface water. Finally, there's likely disconnected streams with a groundwater depth greater than 50 feet below the stream surface. And I want to point out that this is labeled just as likely disconnected. As Melissa mentioned, We want to be as conservative as possible and are not saying for certain that all of these rivers are disconnected. And if you have local data that provides more information, that can supplement our data set. So this new ISW dataset can be viewed in our online web tool called Icons, Interconnected Surface Water in the Central Valley, which can be found at the URL shown here. And I'm going to give a quick demonstration of how to use this tool. And all of the information I'm going to go over can be found in the About panel on the side here. So first, let's go over the symbology, which is showing the ISW status. So streams in blue are likely gaining, streams in light blue are likely connected losing, streams in yellow are categorized as uncertain, and streams in red are likely disconnected. Any streams shown in gray are outside the extent of the Central Valley data and were not included in this analysis. Finally, any streams shown as dotted lines are characterized as canals, ditches, or pipelines from the National Hydrography Dataset. So since these are not natural rivers and streams, they're not included in ISW, but are still shown on the map for reference. To use the map, you can click on the icons in the top right corner here. This one is the layer list. This shows the legend. And this icon on the far right shows the base map switcher where you can change the base map. So I'm going to go over to the layer list where you can turn on other layers to view alongside ISW. ISW shows up automatically and is always turned on. So you can look at natural communities commonly associated with groundwater, which Melissa mentioned, that shows the groundwater dependent ecosystems. You can look at groundwater wells, and you can turn on GSA, groundwater basin, and county boundaries. Finally, the last few layers here show the depth to groundwater data. This includes the raster layers representing the mean, minimum, and maximum depth to groundwater in the Central Valley. And the last layer here shows for each location in the valley how many seasons of data were available and used in this analysis. You can then click over to the Legend tab to view symbology for all layers that are currently turned on the map. So in this example, you can see for mean depth to groundwater, locations in the valley in blue, where groundwater levels are closer to the surface, and locations in brown, where groundwater is far from the surface. And you can see how the ISW status corresponds to the groundwater depth layer below, as connected streams in dark blue overlap with the high groundwater levels, and disconnected streams in red have the distant groundwater levels. So I'm going to zoom in on the map, and as you zoom in, the map will become more detailed and more rivers and streams will appear. I'm going to zoom in on Merced for this example. So you can click on the map to get more information about layers that are turned on. So if I turn on the GSA boundary layers, you can click within a GSA to get the GSA name and basin number. You can also click directly on a stream to get more information. The pop-up box will show the stream name, the ISW connection status, and the minimum, maximum, and mean depth to groundwater. It will also show the years and seasons with data available in that location if you scroll down. So in this example, the Merced River is likely connected gaining on the western side of the Merced GSA based on a minimum depth to groundwater between -1 and -18 feet, meaning the groundwater depth is actually above the stream surface level. On the eastern side of the GSA, the river is likely disconnected, where the groundwater is more than 73 feet beneath the stream surface. If you turn on the number of seasons with groundwater data layer, you can see for the Merced River that the number of seasons with data varies across the river, and this likely disconnected categorization is only based off of one season. So you can use this web map to explore the connectedness of surface water within your GSA. In addition to viewing the data just in the web map, it's also available to be downloaded and analyzed further in ArcGIS. On the About panel here, there's a link to download the data and our full methods. For GSAs outside of the Central Valley who have groundwater well measurements, we recommend following our methods to determine likely ISW in your region. And similarly, for GSAs in the Central Valley, this data set should be used as a starting point to analyze ISWs and should be supplemented with local or more recent groundwater depth data. So thank you for your time, and we're excited for you to start using this new tool. And Melissa and I can take any questions now.
Excellent. Thank you, Charlotte and Melissa. I'll invite you to turn your video back on, and if everyone can please join me in thanking our phenomenal speakers. We have lots of great questions in the chat and in the Q&A function that I have been tracking for our speakers. So I will turn things over to those questions to begin. So the first question comes from Stephen Slack. The question is about the 30-foot criterion for GDEs. They found that some GDEs that use groundwater deeper than 30 feet. When should we be worried about the 30-foot level not being deep enough?
Yeah, so the 30-foot threshold is basically comes from this paper called Canadell 1996. It was a global rooting depth database. And one of the first things that we did at TNC was to compile all the rooting depth data that was available globally as a way to, get an idea of like what type of groundwater levels are these various vegetation reliant on. And the issue is that rooting depth data are very difficult to collect. They're very invasive, like you have to either excavate, and they're very labor intensive. And so there aren't that many for individual species. And also too, a lot of species will have varying capacities to extend their rooting depth based on what water is available and the natural fluctuations in groundwater levels or the aquifer types. And so the 30-foot is an average. And there are some species that have rooting depths that are deeper. And so it really needs to be used with a grain of salt. There's a whole range of tools to be using to verify whether or not a mapped feature in the NC dataset are actually using groundwater, ranging from isotope analysis to more intensive in situ studies. And so we didn't think, in trying to provide guidance at the statewide level for water practitioners, we didn't think it was feasible to recommend like a more resolute method like isotope analysis, because having to sample every NC dataset map feature is just not feasible. So we thought, let's look at depth of groundwater within 30 feet. If there are known cases where 30 feet is not sufficient and you have evidence, by all means, please use that and reach out to me and teach me about it, because a lot of this, my role at the Nature Conservancy has been to basically help provide technical assistance around this, because there isn't a lot of information. And so I've been teaming up with a lot of different academic researchers to help fill these gaps, and also with GSAs that are doing their own work on the ground. And so I'm learning a lot as well. And so if you have specific results that you want to share with me, that'd be great. And then we can help package it in understanding, like, statewide, like what does that mean? For instance, we have a lot of great work happening out of the Santa Clara River. We've been doing a lot of isotope work down there, remote sensing, and we're starting to actually get some like concrete numbers for thresholds, which is fantastic. And maybe because a lot of the species are similar there as they are like the cottonwood and willow species, they're ubiquitous throughout California. That can give us an indication of what thresholds might be needed in another basin. So please reach out to me. I'm happy. I would love to hear more about your ecosystems that are using groundwater deeper than 30 feet.
Mm-hmm. And maybe Melissa and Charlotte, if you could put your contact information in the chat for folks to follow up with you both, that would be great. I think you bring up a great point. This is a 20-year learning process and trying to address many of the data gaps that you elevated in your presentation, Melissa. And actually, that builds on our next question. Can we add data for GDEs in our area to the Pulse platform?
Yeah, so you can't add it to the Pulse platform, but the Pulse platform is built off of code from Google Earth Engine, and we'd be more than happy to share that code with you so that you can upload your shape files. We did this with Sonoma. Sonoma Water Agency is no, not Sonoma, it was another basin. The name is evading me. But yes, we can reach out to me and I'll help, we can provide some technical assistance to help you with that.
Thank you. This next question comes in from the Q&A. Did you investigate the underlying reason or reasons, I imagine, why the plans were lacking in so many areas? I know some of that likely had to just do with time constraints and some of the broader kind of capacity issues, but wondering if TNC's done any additional analysis about the underlying reasons why the plans were lacking.
No, I would imagine, yeah, financial, time, but also I think stakeholder engagement can be tricky, right? Like, how do you, stakeholder engagement is not just like putting a public notice out there to a meeting. It's actually engaging with folks, and you know, doing that for the first time is difficult. I have found that folks that have their GSA governance structures such that there's representatives from various interests, that is a good way to make sure that you're engaging various stakeholders in the process. So I think this is like a socio-political study that needs to happen, and maybe some, you know, we're all still learning about how to engage with each other in an efficient way, and so I think there's still a lot to learn around that. I would love to know the answer to that. So anyone has any ideas?
Yeah, and I do know that some folks at the UC Davis Center for Watershed Sciences are looking at GSA capacity, particularly in response to stakeholder engagement and drinking water concerns. But I'm sure many studies will be done for decades to come on the capacity issues of GSAs and how to address some of those. But I will say the purpose of these presentations and these conversations is also to share the resources that are out there and encourage folks to connect with the Nature Conservancy and some of our other future panelists about some of these issues and topics. This question comes from Paul Jenkin. Are many GSAs trying to use, quote, disconnected as a loophole? And he had a suggestion to look at the Upper Ventura River GSA for an example.
You know, the regulations don't explicitly say that if it's a completely disconnected system, you don't need to consider it an interconnected surface water. But I have seen, you know, in reviewing and commenting on the GSPs, I've noticed that many GSAs are trying to discount shallow aquifers as being principal aquifers. And the definition of principal aquifers in Sigma is, you know, there's this, you know, similarly to like significant and unreasonable effects on beneficial users in the sustainable management criteria section, there's a similarly kind of vague classification of what's principal aquifer, in the sense of what's when groundwater is providing significant and economic quantities of water to surface water. And so that leaves up for a lot of discretion for the GSAs to determine what is a significant and economic quantity of water. And the issue is that a lot of the pumping that's happening in the basins are happening in the deeper regional aquifers, which are larger. But that's not to say that domestic de minimis well users aren't using those shallow principal aquifer, or shallow aquifers that aren't being considered as principal aquifers, or that those aquifers aren't contributing base flow for streams and supporting ecosystems. And so I find that as a very big problem. And in a lot, like in the Tulare subbasin, for instance, the whole shallow unconfined aquifer was dismissed as being a principal aquifer because the total dissolved solutes was around 30,000 ppm, which is considered brackish water or not fresh water and unusable, even though the desalination of groundwater is, you know, way cheaper than importing water in a lot of places. It's like $500 per acre foot versus $1,000 in drought years like these. So I find it very problematic that if we start, you know, I can see it as a loophole for sure for discounting shallow principal aquifers based on water quality, and also based on, you know, what significant and economic quantities of water are. And just to give an example, in Ventura, where we developed the GDE guidance document, in Fox Canyon, there was a semi-perch aquifer. It's not the regional pumping aquifer. It has really crap water. The TDS levels were 23,000 ppm, which is like nearly seawater quality, and way higher than 3,000, by the way. and they still considered it a principal aquifer because we had a water table there. It was providing base flow to the stream, to the Santa Clara River. It was also providing groundwater for a groundwater dependent ecosystem. And even though it wasn't being actively used for like production for agriculture or other uses, the Fox Canyon decided to classify it as a principal aquifer because it had the potential of being used for significant and economic quantities of water, especially when you start having pumping restrictions in the main aquifers, right? You're going to get more creative about producing new water, desalinating and treating that brackish water for other uses. So yeah, it's a concern I have for sure.
Yeah, and seems like a localized consideration really needs to be taken into account.
I'm hoping that the AEM surveys that the state's doing will help clarify. Like, let's get some objective analysis of what's a principal aquifer or not.
Right. Yeah, definitely need state support on that. This next question I answered in the chat from Steve Hayes, who was interested in knowing what parts of the GDE analysis are legislatively required and what's based upon voluntary or non-regulated best practice. So I shared TNC's kind of initial document and the GSP review checklist, but wanted to give you the opportunity to add anything else to that question.
Yeah, I mean, ultimately it depends on what the Department of Water Resources, how they review the plans, but in the GSP regulations, there are very specific mentions of how beneficial users of groundwater need consideration throughout the whole development of the whole plan, from identifying what they are to developing the sustainability goal and the sustainability management criteria and the monitoring networks and projects. And so, and groundwater dependent ecosystems are a type of beneficial user of groundwater. So they fall under that category, and anywhere else where there's explicit mention of, groundwater dependent ecosystems. So early in the days, we very much studied that the GSP regulations, and we've compiled all the references to groundwater dependent ecosystems there in those two references that Emily's going to share with you.
Yeah, and we can share links to all of these wonderful TNC resources in the follow-up along with the recording. This next one came through the Q&A. This is from Jameson Crosby. Is TNC going to do a similar analysis for other parts of the state? It sounds like you are planning to review all of the 2022 plans. Is that right?
I think maybe this question is maybe for Charlotte in regards to getting the ISW mapping for the outside of Central Valley.
Yeah, I think you're right.
Yeah, that's how I took this question too. We don't have any plans to right now. The way that we've done the ISW tool is to get kind of a big picture across the state using easily accessible data, and DWR only has that for the Central Valley for these years. So if there are other statewide data sets that you know of, we would kind of love to look at that, but we don't have any plans to do that right now.
And actually, Charlotte, we have a few questions here for you that came through the chat. This one is from John Rosenblum. In the Central Valley ISW, what about data before the 14-year range and considering historical depletion of groundwater resources?
I think I would say the same thing. If DWR had the data available prior to 2011, that would be great to incorporate. So if you know of data sets, then we would be interested in looking at it further back, but we don't have that right now at this time.
Just to chime in really quick, we did do a report with RMC 6 or 7 years ago. I think there's a link in the Maven's Notebook ISW page to that report that we mapped interconnected, basically gaining reaches throughout the Central Valley, which has a more historical look at it. So that might be of interest to you, John.
Great, and we can relink that ISW Maven's Notebook page as well. This one comes from Stacy Schutzen. Again, I think this is for you, Charlotte, when you were going through the mapping. Is there any way to understand why in certain locations an area may be yellow versus blue? That might be.
Yeah, so the yellow is kind of this in between area where we can't say for sure whether it's connected or disconnected because of the cutoff values, which we got from the literature on interconnected surface water that are kind of established throughout of what's, strongly likely connected versus disconnected. And there is this gap in there between the 20 and 50 feet where we don't take a strong stance either way. And that's going to depend on, if you know of groundwater well measurements in your area that can provide more detailed information that isn't available at the statewide level.
Okay.
I'm not sure if you have anything to add to that, Melissa.
Melissa,
No.
did you?
I shook my head.
Okay, sorry, I missed that. Great, thank you. This is a question coming in from William Medlin. How many years of groundwater data must be analyzed and averaged when assessing the NCCAG data sets against groundwater level data for determining whether or not GDEs are actually present within a specific basin?
Yeah, so they are, we recommended 10 years. So like 2005 to 2015, because that's what the Department of Water Resources recommended for, how you develop a water budget. Like they don't say develop your current water budget based on 2015 spring conditions. That doesn't make any sense. So we recommended that, but like as I mentioned in the presentation, the shallow monitoring wells are a massive data gap, and so that's why it's very important that a conservative approach be used, and you retain any questionable polygons as potential groundwater dependent ecosystems until you have more data to remove them. And so a lot of times it's just a data, as much data as you have essentially, but ideally 10 years. So you get that like multiple water year types and seasonality.
Yeah, and I think you actually in your response answered Emily Reinhardt's second question about why the number of wells in the data sets is very limited. I think it's just lack of data in a lot of these.
Yeah, I mean, prior to Sigma, the surface was the boundary condition in our models. Like we have most of our monitoring wells in the center of our basins where the pumping is happening, and we never had to consider what was happening at the top, what's happening at the bottom, really. So it's just but the Department of Water Resources has been allocated some budget funds as part of like the I think it's about $49 million that DW is going to have, and part of that's going to go towards enhancing groundwater monitoring near disadvantaged communities, interconnected surface water, groundwater systems, GDEs, and so and I know in a lot of places like siting the wells is a challenge, and so the Nature Conservancy, since we own land wherever we can, we are teaming up with folks, allowing them to install wells on our property so that we can monitor conditions in the basin. But we don't own property in all the 517 basins throughout the state.
Mm-hmm.
And it also the DFW might be a good place to reach out to for lands, or any other type of public trust or land trust might be a great way to help fill in gaps if access to land is a kind of a constraint when you're prioritizing how many wells to put in and where to put them.
Right. Yeah, it's definitely a question across the state that's trying to be addressed. All right, we've got 2 questions left in 3 minutes. Let's see if we can do it here. We've got a question from Reed. In the TNC ISW analysis, what methods were used to define the vertical bounds for the connected, disconnected, and uncertain classes? Were geologic characteristics included, and if so, how?
Yeah, so I'll just really quickly say that we used those cutoff values based on some of our research into the literature that already exists on ISW. We didn't come up with any kind of new cutoff values to decide those. So that's already established.
Okay, great. Last question then, and this is very timely, knowing that some of the GSP determinations just came out the end of last week, if you missed the Maven's Notebook update or DWR updates. Once the final GSPs have been approved by DWR, do we get another chance to comment in the future for the updates that the GSAs give to DWR? Yeah, we're wondering if you could share a little bit more about how TNC will be involved in that process.
Yeah, I mean, so every 5 years there's going to be a new groundwater sustainability plan, and so there should be public comment periods with that. Right now, it's going to be a very busy summer and fall for me and our team to review all the draft GSPs that are coming out before they get submitted to DWR, and it is a little challenging to track them. We have a spreadsheet. We've gone into spatial analysis, figured out which GSAs are there, which ones are creating GSPs, and we found out that there was 64. We're going to try to make that data set public so that other folks who want to comment on plans don't have to do that tedious work. So feel free to email me if you want to get that ahead of our release of that. But so they're reviewing the plans, and then once they're submitted to the state, then they're on the GSP portal. But it's not really helpful to comment on a plan that late, because then it can't really be addressed until the final 5 years, until the next 5 years. So, I mean, anything's better than nothing, but that's why we try to comment on the plans when they're in draft form, so that we can try to provide some helpful feedback while there's still time to remedy it before the submission to DWR.
Absolutely. And we can also include the link to the GSP portal. I know we are at time, right on the hour. So I just want to thank you again, Melissa and Charlotte, for joining us today. I did include a link in the chat to register for our upcoming webinars. Our next one is taking place on June 28th, and we'll focus on drinking water and disadvantaged community engagement. So highly encourage you to register for those. And we will be sharing the recording from today's conversation with you all following the presentation. Thank you all.
Thanks. Have a great day, everyone.